Imagine a Tesla that costs less than your monthly rent, and yet drives like an $80,000 EV. We're witnessing the moment Tesla shifts automotive history. For 4 long years, millions have waited, speculated, and doubted the possibility of a true mass-market Tesla. And now, it's happening. The trial production of the Tesla Model 2 and its first working prototypes have officially begun. Elon Musk isn't teasing anymore. He's cutting through the noise, signaling that the future of affordable electric cars is no longer a rumor, but a reality. This isn't just another EV. It's the strike that breaks through decades of automotive tradition. Evidence is everywhere. Gigafactory Texas is drilling new switchgear mounts, wiring megapack trailers, and running crash tests. Nevada is expanding 4680 cell capacity, while Mexico is quietly constructing the world's next automotive powerhouse. Tesla's manufacturing network, prepared in silence for years, is finally switching from planning to full motion. And what you're about to see could change the way every car is built in the next decade. Today we're breaking down exactly how the Tesla Model 2 will redefine car manufacturing, outperform rivals while cutting costs, use its battery as a structural spine harness software to make a 15,000, 19,000 vehicle feel like an 80,000 luxury EV. Buckle up. This is a deep dive you won't want to miss. How can the Model 2 redefine how cars are built? What if building a car could be as simple as snapping together a smartphone? The Tesla Model 2 isn't just a smaller car. It represents a fundamental shift in automotive manufacturing. Traditional factories assemble vehicles linearly. Hundreds of steps, thousands of parts, endless labor hours. Tesla asked a simple question. What if we approached car manufacturing like building a modular smartphone instead of a steel and welded Lego tower? The Model 2 is built using a modular, unboxed assembly system, where front casting, rear casting, battery spine, interior module, and electronics frame are constructed in parallel. These modules snap together during the final assembly stage. Assembly times are brutal. Where a conventional EV takes 10-14 hours, Tesla prototypes hit 4.76 hours. That's a complete revolution. Think about it. Double the cars with the same workers in half the time. Implications: same workforce, double output. Same factory footprint, double vehicles. Same capital, double revenue. Mexico's Gigafactory in Nuevo León is central to this strategy. Its proximity to the U.S. border enables rapid logistics. Labor costs are less than half of California. And the plant will receive batteries from Nevada's 100 GW expansion, creating a seamless supply chain. When Tesla reaches 1 million Model 2s per year by 2028, this will mark a Corolla moment for EVs, the car that finally pushes electric vehicles into mass-market reality. Traditional automakers simply cannot keep up. Would you reserve one on day one or wait to see how fast Tesla ramps up? Comment below as we go. What makes Model 2 stronger than rivals, even while cutting material cost? Fewer parts, stronger car, sounds impossible? Tesla made it real. You might think cutting costs compromises quality. Tesla proves the opposite. Using gigacasting technology, hundreds of welded parts are replaced with a single massive aluminum casting for the rear chassis. Fewer parts mean stronger structure, reduced welding errors, lower weight, lower production cost, and it's not just about cost savings. Aluminum absorbs crash impact predictably, enhancing safety ratings while increasing torsional rigidity. The Giga Press, an industrial titan capable of producing massive casts in seconds, turns this into reality. Watching molten aluminum form a car skeleton in minutes is nothing short of breathtaking. Imagine seeing a car skeleton being created in less than 5 minutes, and knowing it's stronger than 10x more expensive vehicles. The result: quieter cabin, sharper handling, and safer crash performance. Meanwhile, fewer parts and less weight also improve range. Competitors relying on traditional steel and welding processes simply cannot match this efficiency. Tesla has made vehicles cheaper, stronger, and lighter simultaneously. How does Tesla turn the battery into a spine? So Model 2 is lighter, cheaper, and goes farther. What if the heart of your car was also its backbone? The Model 2's structural battery pack is revolutionary. Most EVs treat batteries as cargo, bolted under the chassis. Tesla turned it into a backbone. By embedding the battery into the car frame, heavy cross members are eliminated overall. Weight is reduced, torsional rigidity increases crash. Performance improves, center of gravity lowers range. Extends without increasing. Battery size. This architecture allows Tesla to use less material while strengthening the vehicle. It also supports chemistry flexibility. LFP packs power, early production, for affordability and reliability sodium-ion. Batteries could become a cold weather upgrade for Europe. Aluminum-ion remains a long-term game changer for rapid charging. The battery isn't just energy, it's structure, safety and efficiency, all in one. The battery as a spine is both structural and functional, merging safety, performance, and efficiency in a way traditional OEMs cannot replicate without retooling decades of assembly philosophy. Is software the secret weapon? That makes a $15,000, $19,000 Model 2 perform like an $80,000 one? What if your $15K Tesla could feel like an $80K car? Just because of software? Tesla flipped the automotive script. Hardware is no longer the only driver of performance. Software now defines the car. Acceleration, braking, traction control, efficiency, and battery management are all controlled through code. Features can improve over time via over-the-air updates, meaning your car becomes smarter after you drive it off the lot. This transforms a budget EV into a premium experience. Tesla can unlock acceleration, boosts driving mode, optimizations, AI-assisted autopilot updates efficiency, and range improvements, cabin automation features. Legacy automakers rely on mechanical upgrades. Tesla monetizes software evolution, creating a vehicle that becomes better month after month. For consumers, a $15,000, $19,000 Model 2 can deliver the feel and performance of far more expensive vehicles. And this is just the beginning. Tesla's updates could make your car feel brand new every month. Finally, we're witnessing history in motion. Tesla's Model 2 isn't just another car. It's a manufacturing revolution. Gigacasting and modular assembly/production time. Structural batteries redefine strength and weight. And software elevates a mass-market EV into a premium experience. With Mexico, Texas, and Nevada scaling production and batteries, Tesla is poised to disrupt the automotive world on an unprecedented scale. Prototype phase started, trial production, active, reservations, coming, and you'll see it all happen in real time. The prototype phase has started. Trial production is active. Crash tests and validation cycles are underway. Pre-orders may open soon, and we as a community will witness it all, real time. So here's the question for you. Comment below: A, you're going for early reservation. B, you'll wait for second-year revision. C, you're watching the industry panic first, because when Tesla hits volume, the $15,000, $19,000 EV revolution begins. Stay tuned, stay electric, and remember, this coverage comes to you from Road Zone Reviews. We're not just witnessing history, we're driving it.